Have you ever wondered why you feel lighter in a swimming pool, or that you're able to float? Well, that has to do with density. Density is the ratio or comparison of mass to volume in an object. And mass is the amount of matter in an object, and volume is the amount of space that an object occupies. So it's a ratio of how much matter is in an object per how much space the object occupies. In other words, it's how much stuff is crammed into a space. So how do we measure density? So the metric units for density are grams per centimeters cubed, or grams per cubic centimeters, or grams per milliliter. So before we find density, you have to make sure that the mass is in grams and that the volume is in either milliliters or cubic centimeters. So here's a sample problem. So density equals mass divided by volume. So we have a mass of 5 grams and we have a volume of 10 milliliters. So we divide that out. Our density is 0.5 grams per milliliter, which means that every milliliter has a mass of 0.5 grams. And objects tend to settle or sink based on their density. So objects with larger densities settle to the bottom of something, and objects with smaller densities settle on top of objects with larger densities. So we're looking at matter. So it's how tightly packed matter is, or the amount of mass in a given space. So 8th graders will remember back to our talk on solids, liquids, and gases. Our gas is less dense. So there's less, so if each smiley face represents matter, or represents mass, or matter, you can see that there are only a few smiley faces in the square, and the square represents the volume, or the space that the object takes up. So our gas is less dense. Here's liquid, it's a little bit more dense. And then our solid is the most dense. So it has the most mass in the space. So in the two examples down here, the two squares, this one here is less dense, this one is more dense. So let's talk about the density of water. So water has a density of 1 gram per milliliter. So for every milliliter, every milliliter of water has a mass of 1 gram. So objects with a density of less than 1 gram per milliliter will float. They'll have a positive buoyancy. Objects with a density greater than 1 gram per milliliter will sink. So that's our anchor. So our object with a density of less than 1 gram per milliliter is our boat. The object with the density greater than 1 gram per milliliter, which sinks, is our anchor. And our objects with a density of equal to 1 gram per milliliter, which is our fish here in the fish tank, they stay suspended in the water column. So they have a neutral buoyancy. They don't float, nor do they sink. So how do we change an object's density? There are 2 ways that we can change the object's density. We can change the object's mass, or we can change its volume. So if we want to make an object's density smaller, we need to either increase the object's volume, so we're keeping the same amount of mass, but we're going to be spreading it out over a larger space, so that's making it less dense, or we need to decrease the object's mass, but keep the volume, and we can keep the volume the same. So then there would be less mass in the volume, in the space. So, for example, if we had like a jar of M&Ms, and then we ate them, or ate several out of the jar would stay the same size. It would now have less mass, so it would be less dense because you've taken some of those pieces out. If we want to make the object's density larger, we either need to decrease the object's volume, so we need to make it smaller in size, or we need to increase its mass, so we'd be adding more things into it. And both of those things would make the object's density increase. So that would be putting more M&Ms into the jar. Like refilling the jar would then increase the mass. The volume would stay the same because the jar wouldn't change. And that would increase our density. So let's look at a submarine. So I don't know if you've ever wondered how a submarine works. So if a submarine is under the water and it wants to surface, so it wants to come back up to the surface, it empties the water from these holding tanks called ballast tanks, and it decreases the submarine's mass, and it makes the sub's density smaller, causing it to rise. So these are the ballast tanks in the submarine. So let's say, so here the submarine is submerged, right, but it needs to surface, so it starts to drain those ballast tanks. So it's decreasing the mass, but the volume is staying the same size because it's not getting any smaller. And so it's decreasing the density, enabling it to rise, and then eventually surface. And then when it wants to dive, so now we have our submarine, it's on the surface, it needs to get under the water. It's going to open those tanks, those ballast tanks, fill them with seawater. Again, it's not changing the volume, it's only increasing the mass. So it's going to increase the submarine's mass and makes the sub's density greater and causes it to sink. So then its density becomes greater than 1 gram per milliliter. Now, let's talk about air density. And we touched a little bit about this in a quick think. So cold air is more dense than hot air. And we talked about this. So the particles, right, because it's colder, that causes those particles to condense and get closer together. So in a given amount of space, you'll have more particles of cold air than you do of warm air, right? And when it's hot, think about it like this, like if it's a hot summer day, your air conditioning's broken, you don't really want anybody touching you, right? Like I know, my kids, I'm like, please don't sit on me, hang on me, like when it's, 100 degrees and I'm outside. I just don't want to be touched, right? Because it's hot. So think of it that way. Cold air, right? It's cold. You're freezing, you're going to huddle together, with your friends, right? You'll physically put your arms and cross your hands together because you're trying to keep warm. So it's kind of the same concept with air. So as it gets higher, so you've got this denser, cooler air, right, around this hot air balloon. That's how the hot air balloon works. So you've got the force of the buoyancy, so you've got the heat that's rising, right, it's spreading out those particles, so the air inside the balloon part of this hot air balloon is less dense than the air surrounding it, so that's what enables the hot air balloon to rise. And so, another way that you can change density is changing the temperature of the object. So when you heat an object, you make its density smaller. And the reason that happens is when you heat an object, it expands and it makes the object's volume greater. So the mass stays the same, but the volume increases. So that makes the density smaller. So that's an inverse relationship. So when you're cooling an object, you can make the density larger because the object contracts, making the volume smaller. Mass stays the same, volume gets smaller because it's contracting, which makes the density larger. And this is why warm air rises and cold air sinks, because warm air is less dense than cold air. All right, now go to the Edmodo, and take the quiz. Make sure that you have visual notes on these slides.